Next slide. Chaos theory. I don't know how many were down at the end of the table where I was talking with Joe last night, but we talked a little about chaos theory last night. And it turns out Joe is a physicist. He worked on chaos theory for his master's degree, so he knew quite a bit about it. And as it turns out, I got interested in chaos theory, or almost seriously interested in it, just maybe a month ago. I was kind of out of the academic loop by the time chaos theory came on the scene. Chaos theory really got its initial start in the 70s. Probably early 1970s, people started saying, well, this is really weird stuff we're getting here. What does it mean? And then it kind of got from a very minor thing in a few universities to kind of a big deal where people were doing it all over. It was the newest, biggest thing through the 80s and 90s. And then you don't hear that much about it anymore. It's kind of quiet. But it's not that it's gone away. I mean, people are still crunching. You don't hear about this double slit either. Every time I do double slit, people are going, really? It works like that? You know, that particle goes through both slits at once and then distributes itself like a wave on a back. You know, couldn't be like that. Well, this was done in, you know, 15 or, you know, early 1900s. I think the Copenhagen, which was they call it interpretation. It wasn't an interpretation to begin with. Copenhagen was a statement of the results of the experiments they did. All these double slit experiments were done to try to figure out how reality worked. And after they had done them and done them and done hundreds of them, they had enough data. So a whole bunch of people got together in Copenhagen, Denmark, where Niels Bohr was from, and he was kind of the organizer of it. And they looked at it and they said, well, here's the data. What is it telling us? So they came up with these statements about reality that they got from the data. And that's what it was. It's like, these are our experimental results. Well, some years later, when most of those were dead and gone, and physicists got more and more anxious to be more material again, didn't like that Copenhagen result because it was so airy and you know, non-physical, changed the name to the Copenhagen interpretation. Now there are lots you see of interpretations in Copenhagen. Well, that's just some other interpretation. That's just another one. It happens to be the only one that's always right. But other than that, it's just an interpretation. You don't have to take it too seriously. So that's what everybody knows as the Copenhagen interpretation. It wasn't an interpretation until much later, but now it is. So I knew about chaos. Every technical person probably knows about chaos theory to some degree, but I hadn't really brushed against it because I was out of graduate school by the early 70s. And all that took place mostly in universities. It didn't make a lot of practical applications, and still doesn't have a lot, but it does have some. And so I was reading a book that was recommended to me. And in this book, the writer made a statement. He said, it will be, and he was actually quoting some famous person, and he said, it will be recognized in the future when people look back at the 20th century that there will be three major scientific discoveries or scientific great leaps forward. Three big deals. One of them will be relativity, one will be quantum mechanics, and the last will be chaos. Those are the three big things for that century. Maybe even for the next century too. We don't know that yet. But those were the three big ones. So I said, well, really? You know, I didn't put it in that kind of category, but then I was kind of outside of that loop. I didn't need it in the work I was doing. So I read something about it because I was thinking like this. With relativity, the math works, but nobody has a clue why c should be a constant. Speed of light should be constant. Well, virtual reality, if you've heard my lectures, virtual reality determines that c should be a constant because it's related to the resolution in time and space of the simulation, of the virtual reality. It's part of It's related to the size of a pixel, if you will, of space and a pixel of time in our virtual reality. And quantum mechanics, well, the math works fine, but nobody knows why representing particles as probability distributions ought to work. I mean, why probability distributions? That's bizarre. Well, my big toe has come to the conclusion that, well, it's because they are probability distributions. It's a probabilistic calculation because that makes sense. Anything else is too hard to do. You take your deterministic rule sets, you make the probabilities, then you do random draws from the possibilities, and that's how you run this virtual reality. That's how you render things here. What's rendered in this reality are the random draws out of the probability distributions of the possibilities. It's the way it works. So that's why they're probability distributions. So is everything else. So I answered that one, and I said, I wonder if I can figure out what's going on with chaos. So I read this book on chaos, and it turns out that chaos means that you can have some little change, often even down in the noise, and that change can have a big effect. That creates chaos, because when noise and little tiny things start making really big things happen, it gets chaotic. Now, chaos doesn't mean randomness. We kind of think chaos is when everything's random, right? But that's not what chaos in this term means. This is the science of chaos, and this means that small things can make very big differences. And they first looked at this by looking at fluid flows. If you look at a fluid flow, water running through a pipe. If you look at a fluid flow, if the fluid is flowing slowly, it's nice and even. We in physics call that laminar flow. Everything's even. The water just runs through the pipe. You make the flow a little faster and a little faster, you start getting little eddy currents in it and swirls, and of course the resistance to getting through the pipe goes up, so there's a problem there. But then you keep putting the water through faster and faster, and everything goes nuts. The water starts to churn in all sorts of ways. It's not stable, it never changes, and if you look at it over a year, it never changes. The same states don't repeat. It just goes on and being totally nuts. Well, you make the water go even faster yet, and suddenly you get little parts of equilibrium. You get little patches of steady state solutions where now things start to be calm, but all around it is a swirl of mess, and right here in the middle of it is this little piece of calm tranquility. And this calm tranquility moves around. In other words, it disappears here but gains something over here. And they go here, there, and now maybe there's two little pieces of tranquility. So you have these odd things where the chaos creates what looks like chaos, but at the same time, it also creates patches of stability. And then they found that in the real world, chaos is everywhere. It's only in that kind of simple part of the world where everything is linear and everything is behaving regularly. Everything is steady state. That's the place where physics likes to work, because that's where the equations are simple. When you get to chaos, there are no equations. Well, there are differential equations. Chaos is created by 3 differential equations with feedback. If you're a math person, that means something to you. If you're not, don't worry about that. But that's how they're described. So anyway, why do they work like that? Why do they have these islands of tranquility and all of this mess? And there's certain characteristics of it. And you can learn about chaos and how certain things will have patterns of tranquility, and these patterns will replicate. And they tie some of this into fractal processes as well. They start looking at things that look like fractals coming out of this process. So anyway, I read the book and thought about it, and I think I can explain why chaos works the way it works. So what they don't know about chaos, they know a lot about it, but they don't know why it should be that way. Why should you get these little pools of tranquility, and why do they change, and that sort of thing. And it occurred to me that it's a result of the fact that the way this reality is rendered is that you take a random draw from the distribution of the probabilities. That's how you get it. as you raise and raise, let's say the amount of water going through a pipe, as you raise that parameter up, the number of possibilities goes up with it. Because now, yeah, there's little bumps in the pipe, there's a little, thing here or that, or a little scratch mark, there's something. And at low velocities, well, the water just kind of moves around it. At the high velocities, that creates a problem. So it starts a vortex, which creates other problems. Well, all of these, you think of the water as you have these little pixels of space, little 3D pixels everywhere in the water, and you have to keep track of where they all go. Are they swirling? Are they moving straight? Where are all these things going? Well, when it's a nice laminar flow and they're all moving along together, the choices are just that they all move along together. Yeah, there's a little tiny, getting out of line here and there along the edges, but there's not a lot of choices. It all just does what we compute a steady state to be. But then as you get more and more flow, the choices go up. Now things are interacting in the margins with tiny things setting off major reactions. So the choices go way up. The number of possibilities go way up. Okay, when the number of possibilities go way up, that does a couple of things. One, when you have lots and lots of possibilities, and you're making lots and lots of random draws because there's so much happening with these little spots of volumes of water that we're tracing through this water. There's so many of those random draws that you get a lot more coming out of the ends, out of the wild stuff that's out at the tail of the curve, the stuff that's only 1 in a million. Well, if you got 100 million things going on, you got 100 of them coming out from under those tails, extreme tails of the curve. And those things are really unlikely. But now you've got a lot of unlikely things going on in there as well as the things that are probable. Okay, so that's one thing that's going on. Every time you get more things that could possibly happen, each one of those things, you see, you have a lot more of them, then that generates activity, which generates even more things that can happen. So it begins to kind of cascade. It builds. You have the more interactions are caused. In other words, as long as it's smooth flow, little tiny bumps, no problem. But now let's say I hit a little snag someplace on the inside of my pipe. Maybe it's just a molecule out of line. And I hit something there, and that creates a little tiny whirlpool. Now at the highest speeds, it creates a whirlpool that now is going to modify hundreds of thousands of these little molecules. Now they have different probabilities. Before they only had one thing. They were going to go in a straight line. Now they've all got these wild things. And those wild things are going to cause more wild things. So that's what chaos is. It's like a positive feedback. Positive feedback is a double E term for when the feedback keeps the process continuing on. For an example, if you had a car, you have a car with cruise control. Cruise control is what they call a hunting servo. If you go too fast, it slows you down. If you go too slow, it speeds you up. It's always trying to find the equilibrium point in the middle where you set it. That's negative feedback does that. Positive feedback would be a car with a cruise control hooked up so that the faster the car goes, the more accelerator pedal goes down. So a car goes just a little bit of speed, well, so it increases it. The more it increases, the harder it pulls the accelerator down. The more it goes then, very soon your car is going at maximum speed and it's going to keep going that way until it crashes or the engine blows up or it runs out of gas, right? It's just wide open. In other words, it keeps building on itself. I'm talking about double E circuits and things. They talk about positive and negative feedback in a circuit. So it's that kind of a thing with the chaos for a while. But you've got these constraints. You see, you can only change things in as much as they abide by the rule set and that they maintain history. You can't change anything that it doesn't follow from what was before. Okay. So when you have these strange things going on out at the ends of the curve, they can do things that are it could be a very hard act to follow. There may not be a lot of things that will connect to that, or there may be, depends, but you have these constraints. And these constraints will force little pools of calm now and then in the system, because you'll get to a point where there just isn't much else you can do. The probabilities are not so many, not so effective. So I think it's the constraints that force the little puddles of whatever. But it's just a speculation. It's just a speculation at this point. I don't know that it'll work out that way, but it just seems to me intuitively that there may be a connection, and we'll see. That'll take a lot more reading and research to see if we can make that formal. Take a pretty good sized computer too to do that. Hopefully somebody will hear this and get interested in doing that, because chaos is kind of still an interesting subject to a lot of people, and see if they can't duplicate the effects of chaos just by keeping track of the possibilities and randomly drawing from those possibilities for each event, because it's got the right stuff to create the chaos, and it's got the constraints to limit it both, which is what you see in chaos. You see this wildness, but you see constraints impose themselves at various places. That's just a point. I thought I'd point that out and see if I could get some enterprising people to work with that. The last one, you know, I've been, this is for probably, I don't know, 20 years or so, long before I ever put pen to paper with My Big Toe, I was thinking about writing a book about gender. And so it predates the My Big Toe book. Mostly I've done it in my head. I did write some down a couple of decades ago, but added to it then maybe, I don't know, it was about 5 years ago or so. It's on my website if you want a little bit. I've got the what I'd call the logical structure of it, probably 50% of the logical structure of it laid out. I haven't filled it out yet, what all the logic means and the ramifications and that, but I got little pieces of it. If you go to www.mybigtoe.com, and I'm not sure what it's under, but if you play with those little tabs, you'll find one of them that'll take you to this. I think it's under downloads. Will take you to this. It's short, 20 pages. It's just kind of an outline. But anyway, the reason I wanted to do it is that I could see and still see a very large social and individual dysfunction around gender issues in our culture. And my point is to try to provide a bigger picture of those issues. What do these issues look like if you strip away all the cultural stuff? You strip away all the beliefs that we have. If you get rid of all of that, you can get the ego out from being intertwined with all of that. What do you have left? What's the fundamental relationships here, right, between male and female? So I was just hoping that that would be helpful to a lot of people, because there's a whole lot of people that struggle with those kinds of issues. And I would like to be helpful if I could by giving them some of my insights and see if it helps them. Anyway, so what I'm looking at is human instincts. That's what's fundamental. You get down to the basic fundamentals, it's instincts. And yes, we have instincts just like every other animal. The human species is another animal on this planet, and we don't like to admit that we have instincts. Animals have instincts. We control everything with our intellect. We don't have instincts. Nothing pushes us around. We only do what we want to do. That's another fable that we can convince ourselves is real. That's probably even more prevalent than electromagnetic fields. We all kind of feel that way, but we have a lot of instincts. There's a lot of our behavior is coming right out of our genetics. Our behavior is particularly around those issues that have something to do with survival and procreation. Those are the two big criteria for evolving, for being a species. If we didn't focus on those two, then we wouldn't be here as a species. We would have been extinct. But we have managed to evolve and succeed, and a lot of that has to do with our instincts around survival and procreation. And if we understand what those instincts are and how they affect us, and so many of the decisions that we think we're making for a good reason are really we're justifying because it follows along with our instincts, or we're struggling against our instincts. And if you struggle and struggle, in opposite direction to your instincts, you're going to drive yourself nuts. It's a very high anxiety thing to do. Instincts say do this, you say do the opposite. That's a lot of stress is involved in there, constant stress. So coming out with this idea of what are our instincts, what are the basics, and how does that affect us, and how does it play in our culture is really what this book is all about. And another reason it's taking me so long, well, my big toe kind of got in the way. It got to be to where I have to spend a lot of hours with it. But besides that, I don't think the time was right yet for that book about gender, and I'm not quite sure it's right now, but it's getting close. So it's getting closer and closer to where I think it can be read and understood as it is without a lot of ego and belief issues with it. So anyway, that's where that is. I'm still thinking about it. The book grows every day, but it's all up here. The only thing I've written down is what you can read on my website. I've got, and that's 20 pages. I've got another 400 pages, up here. I haven't committed to writing yet, but I'm fleshing them out pretty well. I got the ideas and where they're going, and fleshing it out will be the easier part. The harder part's figuring out how it works. So that's coming along. I was just asked to do a little report on that since people say, when is that book coming out? I said, well, I'm working on it. Well, that's it, which means it must be time for lunch. And since we're going to break at 1 and it's 12:58, that was luck. Nothing but luck.